Hi everyone, I'm Chris McGuire from Blue Roof Orchard. I'm going to talk today about thinning fruits in an organic apple orchard using the pollen tube growth model. I'm going to start by giving a quick introduction to the orchard that my wife and I operate, and then I'll talk a little bit about the general principles of fruit thinning and crop load management in apples, and then describe what the pollen tube growth model actually is and how we experimented with it on our farm. I want to say that there's some links below this video in YouTube to further resources on the things that I'll be talking about. So my wife Yulia and I started Blue Roof Orchard in 2003. We own 12 acres in southwestern Wisconsin between Madison and Dubuque, and our farm is certified organic. We started out actually by growing vegetables, not apples, and we were formerly known as Two Onion Farm. In the 2010s, we transitioned from vegetables to fruit, and currently we just grow apples commercially with about 3.5 acres of apples that we sell through a community-supported agriculture program, as well as to grocery stores and processors. So what is thinning fruit, and why do we need to do it? Many apple trees have a kind of natural tendency to set too many fruit. So they'll be really loaded with fruit, which tends to lead to a small fruit size and sometimes not great flavor, and also poor bloom in the following year because the tree essentially gets exhausted and won't flower heavily in the next spring. And this then can lead to kind of a biennial cycle where the trees flower really heavily and have a lot of fruits one year and then very few the next year and then heavy again and so forth. Should also say that undercropping or having too few fruit is not really desirable either. Obviously the yield and revenue is less from an orchard, and also because the fruit tend to be kind of watery and bland in that situation. So as an organic apple grower, how can we manage our crop load and thin the fruit? Well, there's a few different stages when that can be done. First of all, there are bloom sprays. So these are things you could spray on your trees during bloom to essentially kill some of the flowers. So not all of them will set fruit, and you'll be regulating the number of fruit by doing that. And in organic farming, there's a few different options there. A common one is liquid lime sulfur, which is really a caustic product, sometimes mixed with oil that will burn the flowers and kill them. Some other options are potassium bicarbonate. That's kind of maybe a milder product, both for people and for the plants. Not really widely used in the US to my knowledge, but there's definitely trials from Europe in particular showing that it's effective. Another option, which I'll be primarily talking about today, is regalia, which is a biofungicide that's allowed for controlling diseases in organic production, but trials have shown that it also can at the same time sort of kill flowers and thin out a crop of fruit, especially if it's mixed with a spray oil such as JMS stylet oil at the same time. And then on that note, oil alone has been shown to have some effect as a bloom thinning spray, though again, it's not really commonly used in the US. Something to keep in mind is that most of these products are not labeled specifically for bloom thinning in apples or in other crops. So you're really, then legally you have to use them for other purposes and achieve thinning as kind of a side effect of the labeled use. So a similar possibility is that in addition to spraying during bloom, you can spray a little later on in development when there are small fruitlets on the tree. There are fairly few products allowed in organic production that are effective at this stage. There's one called Protone, which is kind of a natural plant growth regulator that may have some effect as a thinner, but there aren't too many options. So this is not really widely done in organic orchards to my knowledge. And the third option, which everyone probably falls back on to some extent, but isn't really desirable, is hand thinning, where you're going out there in June or maybe early July and manually removing fruitlets from the trees. And this can be effective, but it's just really labor intensive and hard to accomplish it in a timely manner. So what is the pollen tube growth model? This is essentially a tool for helping growers to time their bloom thinning sprays. So the tree may be in bloom for a week or two, and when during that period should you specifically be spraying to kill the flowers so that you don't kill too many and not have any crop, but at the same time kill enough so that you have a moderate, desirable level of fruit. And this is something that I'm not involved in developing. It was developed by researchers, scientists who took a lot of careful data that's underlying the model. And there's more information on all that, again, in the notes under this video on YouTube. I'll just give kind of a brief overview so you can understand what's going on with this model. Start with a little floral anatomy here. So this is a close-up of an apple flower. And in the center, you can see that there are several 5 pale green stalks coming up. Those are the female organs of the flower. At the top is the stigma, which is sort of a fuzzy, sticky surface where pollen grains will land. And then there's this long green tube or stalk going down from the stigma to the base of the flower. That's called the style. And at the base, there's the ovary, which is, you can't really see in this picture, but is a round greenish thing that will be the future fruit, potentially. The other structure that's present here is around the outside, and those are the male organs called stamens, and they also have sort of a whitish stalk, and at the end of it is an anther, which is a sac that basically opens up and splits to release the pollen grains. So this slide is just trying to show in very simple diagrammatic fashion what goes on in a flower that leads to a fruit developing. So this is kind of a time series from the left to the right. So on the left, you have a flower that's newly opened. I've shown the carpels, the female organs in green, and then the male stamens are yellow. And that pale green globe at the base of the flower is the ovary, which could develop into an apple. The second picture shows that a pollen grain, shown by a little yellow circle here, has landed on one of the stigmas. In the third picture, that pollen grain actually germinates, sort of like a seed germinates in the soil. It germinates, and a stalk, a tube, grows out of the pollen grain down into the stigma and down into the style towards the ovary. And the fourth picture shows that eventually that pollen tube has grown all the way to the base of the style and into the ovary, where, as shown by the black star, it has fertilized an ovule, which will become a seed. And if several of the ovules in the ovary get fertilized, so that there'll be a decent number of seeds in the fruit, and the fruit will probably develop and become a mature apple. So, pollination is the process of bringing a pollen grain to the flower. That's what a bee does. Fertilization is when that pollen grain has germinated, grown into the ovary, and fertilized an ovule to form a new seed. The next few slides will show what the pollen tube growth model is aiming to do and how it aims to work. So in this diagram, we have one open apple flower in the center. And on either side of it, there are a couple of green buds that have not yet opened, but they will become flowers soon. And that flower is freshly opened. It's the king blossom in this flower cluster, and it's ready to be pollinated and maybe to form a fruit. In this slide, a pollen grain has been brought onto that flower by a bee. The other 4 flowers still aren't open. In this one, a few of the other flowers have opened up. So now there's 4 flowers open That one in the center opened earlier, so it's sort of ahead. And the pollen grain that landed on that flower has now germinated, and the pollen tube is growing down the style, although it has not actually reached the ovule yet to fertilize it. A little later, an ovule in the original king bloom has been fertilized. Meanwhile, pollen grains have landed on the 3 other flowers and they've germinated, but they're a little bit behind, and they have not actually had time yet to reach the ovule and fertilize it. So this is the time when you want to spray, according to the pollen tube growth model, because you could kill all the male and female organs in all these flowers, but the original king bloom, the one that was earliest to open, will still develop into a fruit, even if you kill all the styles and stigmas at this point, because it has ovules that are fertilized and it has seeds that are ready to develop in there, and it can form a fruit. The other 3 flowers will just get killed and will fall off and never form a fruit because their ovules have not been fertilized yet. So boom, we've sprayed, we've killed the 4 flowers, but there's one flower there with fertilized ovules that will become a fruit. Notice that there's still a 5th flower that still hasn't opened yet. It's still just a bud. In the next slide, the 5th flower is open. There's a pollen grain landed there. So if we don't want that one to set fruit, we need to spray again to kill that flower. And that's what's happened. And now our job is done because all the flowers are dead and only one of them will form a fruit. The point of the pollen tube growth model is to guide a grower to actually accomplish what I sort of just showed in those diagrams. In other words, to apply sprays at the correct time so that only the flowers that we want to form fruit can actually form fruit, and the rest of them will get killed and never develop into fruits. So what is this model? Well, it was, I said, developed by researchers who very carefully measured how fast a pollen tube grows through the style. And they found that it's determined by temperature. You can see in the graph on this slide that pollen tubes grow fastest at kind of warm but moderate temperatures, around 80 degrees. If it's colder or warmer than that, the growth declines and becomes slower. And the pollen tube growth model uses this to predict when the ovules in a flower have been fertilized. So the kind of the variables, the things that the model takes into account are the variety of the apple, the temperatures in the orchard, and when the flowers open. So in other words, someone has to go out in the orchard and tell the model, like, hey, as of this time, there are enough flowers open in this orchard to give the yield that we want. Or to say it another way, if we want 50 flowers on every tree, now there's about 50 flowers open on every tree. And with that information, the model will then do its magic and tell you when you should do your thinning sprays. One thing to keep in mind about the model is that it essentially assumes a perfect world, that pollination is immediate and perfect, or as soon as a flower opens, there's a bee there delivering pollen. It also assumes that the thinning sprays that we do are completely effective, that when we spray, we kill all the open flowers on the tree. Their spray coverage is thorough and complete. Now, neither of these assumptions is presumably really true, but they're kind of just simplifying assumptions that the model makes, and hopefully they're not going to get us into a lot of trouble. The way that most growers are using this model, if they're using it, is through an interface on the internet that's called NUA. You can find it at the website here, nua.cornell.edu. And this will do the calculations and sort of run the model for you if you enter the necessary input. And one thing that NUA requires is it needs weather data. It needs to know the temperatures in your orchard. And for that, the best thing is if you have a weather station in your orchard, such as the one in this picture, that will record temperatures throughout the day and then automatically upload that data to the cloud where NUA can use it to perform the calculations. If you don't have a weather station, NUA can still work, but you'll be forced to use weather data from maybe a nearby station, which may not be totally accurate and applicable to your orchard. A piece of input that the model needs in order to run is that the grower has to go out and measure the lengths of the styles in the flowers. If the length of styles varies between apple flowers, and if the styles are longer, it takes a pollen tube longer to reach the ovule. So that's going to affect when you need to spray. So basically, it's recommended that you go out and for each variety or block that you're trying to use the pollen tube growth model in, you should measure maybe 25 or more flowers and calculate like an average style length and enter it into the model. And as I said before, the other thing you need to do is enter in when the desired number of flowers is open on each tree. So that's a kind of hurried but hopefully understandable introduction to what the pollen tube growth model does and how it works. What we set out to do here with some funding from a USDA SARE Farmer Rancher grant is to trial over 2 years whether we could use this model together with a spray of regalia and oil, which, as I said before, is a possible organic bloom thinning spray, to accomplish a desired level of thinning. And the rationale here was that this pollen tube growth model hasn't been really widely used by organic growers, at least in the Midwest, to my knowledge. So we're kind of trying to sort of test whether it would work and promote it a bit if it did work. There's definitely some issues with trying to make this work, and one of them is that the pollen tube growth model was only developed for 7 common sort of mainstream commercial varieties, Fuji, Golden Delicious, Honeycrisp, and so on. In our orchard, we don't grow any of those varieties, and I know a lot of people who may grow some of those, but many others as well. And the difficulty is that the speed at which pollen tubes grow varies from variety to variety, and if we want to use the model for Liberty, for instance, we don't know how fast the pollen tubes grow there, and we kind of have to make some guess or just assumption, and maybe use one of the varieties that's already in the model instead of Liberty, and hope it works. And this is, a significant issue. It's not just some very, trivial, kind of a minor problem. And what I have in this chart is an example from our orchard. So in 2022, we had a block of the variety Priscilla, where we were trying to use the pollen tube growth model. And Priscilla was not built into the model. It's not one of those 7 common varieties. So what we did was we tried running the model using each of the 7 varieties that are built in, Gala, Granny Smith, Honeycrisp, and so on, and said, what would we do if this was Gala? What would we do if it was Granny Smith? And the recommendations from the model are very different. If it was Gala, the model says, do your first thinning spray on May 13th at 5 p.m. But if it was Red Delicious, you should do your first spray 2 days later on May 15th at 4 p.m. So that's a big difference. And so, in other words, the specific variety that you have matters a lot when you're running this model. So what we decided to do was, for all the varieties that we were working with, none of which were in the model, we used the model for Golden Delicious. Why did we choose Golden Delicious? Out of the 7 varieties that we could have chosen, well, Golden Delicious was kind of an average one with sort of a moderate speed of pollen tube growth. And the other sort of twist we introduced was that we had like 3 treatments. One where we sprayed or tried to spray when recommended by the model. And the other two, we delayed our first spray to varying degrees. And this was to kind of compensate for the fact that we weren't sure if Golden Delicious was really a good surrogate for the varieties we actually had. So we were kind of trying to play it safe and do a few different scenarios and see what worked. And I think in a nutshell, what we found about using the pollen tube growth model is that there's a lot of practical difficulties in a real world setting to implementing it. Number one is just the weather conditions. The model is going to say you should go out and spray on this day at this time, and sometimes it might be very windy then or pouring rain, and it's not really feasible to spray in an effective way. It might recommend that you spray at a really inconvenient time, like in the middle of the night, or it might say you should spray at 11 p.m. in one block and then in another block at 3 a.m. And it's just realistically and feasibly, probably no one's going to do that, especially in an orchard where you have multiple varieties and the model will make separate recommendations and you're trying to implement all of them at the same time. This slide shows an example from our orchard in 2022. So we had like 10 blocks in our orchard, like different variety in a different place, where we were trying to implement the model. And there was I'm looking here at the time recommended by the model for the first thinning spray. And these recommendations were over a 3-day period from May 13th to May 15th in different times for different blocks. And some of them were in the middle of the night, which is indicated by the sort of dark areas. And others were in the daytime, and they were sort of scattered over this 3-day period, starting at 5 p.m. on the 13th, and then there were a few overnight, including at around 1 a.m., and the next day around 1 p.m., and then that night at 10 p.m., and then the next day at 8 or 9 a.m. So, and in a real world situation where you're also contending with, the vagaries of weather and then just the other work and that you have to do as an orchard manager, it can be difficult to really follow this in any close way and do what the model recommends. Another issue is simply the time that it takes to do this. You have to go out and measure styles, you have to enter data into the computer, you have to spend time every day kind of monitoring, seeing what the model is recommending that you do, keeping abreast. We figured after tracking our time, as a ballpark figure, it took us about 30 minutes per variety that we were trying to manage with this model. And that's just, in 1 year, during that week or so of bloom, it took us 30 minutes per variety just to administer and manage the model, not to go outside and do the sprays. That's entirely different. But just to spend the time, as I say, measuring styles, inputting it, working on the computer, 30 minutes per variety. So if we had a diverse orchard with about 30 varieties and we wanted to implement this model for all of them, it might take us about 15 hours during bloom just to do the kind of management work and plus a lot of hours, filling up the sprayer and spraying and so forth. So this is a pretty significant burden that would come with using the model in a diverse orchard. And I think probably the most interesting thing out of all of this is whether this actually worked. We tried using the model. We sprayed regalia and oil at about a 1% volume to volume of each ingredient, as has been shown in some previous studies, is a good thinner. And so we had, as I said, 3 experimental treatments differing in the timing of the first spray, plus a control where we didn't spray any regalia and oil. And we looked at, some response variables, like did the crop load differ between the treatments? Did doing the sprays reduce the time needed subsequently for hand thinning? Did these treatments affect the yield or the return bloom in the following year? And I think the short answer is no, they didn't. We really had no consistent effect of the thinning sprays on any of these variables. So these graphs show that the left-hand graph is for 2022 and the right-hand graph is for the next year, 23. And each colored line represents like one of the 10 varieties that we were trying to work with in this study. And you know, if there was some significant effect, you would tend to see a real trend where, you know, some of the treatments had a lower crop load than others maybe, or, you know, perhaps the control would have a much higher crop load than the spray treatments and so on. And there's really nothing consistent going on in these graphs. And this is showing the crop load in June, right before we started hand thinning. This one is a similar pair of graphs, but showing the time that was needed for hand thinning in June. So you'd hope that the thinning sprays would do some of the thinning and then reduce the time needed for hand thinning later on, but that didn't really seem to be true at all. These graphs show the eventual yield in the fall. And again, you know, there's some variation, but nothing really consistent that indicates that, you know, the treatments were having much effect. And then finally, this one shows a measurement of the bloom intensity in 2023 as a result of the treatments in 2022, the year before, and no really consistent noticeable effect here either. So in general, we did a lot of work and tried to implement the model. We made these sprays with Regalian oil, but we didn't really see any clear effect or result of that. As I said, there have been some published research in the past, you know, done in experimental settings where they found pretty clear thinning effects from Regalian oil used in conjunction with the pollen tube growth model. Some growers have found that. Others have not really seen much effect from spraying these products. One variable seems to be that the manufacturer changed the formulation of Regalia several years ago. They changed not the active ingredient, but one of the kind of adjuvants that's mixed in with it. And they believe that significantly reduced any, you know, thinning or effect, which was kind of their goal. I mean, thinning is sort of a phytotoxic reaction where, you know, the spray is being toxic to the plant, and generally speaking, the pesticide manufacturers want their products not to be toxic to plants, and they did accomplish that maybe with the changed formulation, but the side effect is that it perhaps no longer works as a bloom thinner. So that's one likely explanation for what we saw here. I mean, I will say that when you spray these products, you do see visible symptoms on the flowers. The picture on this slide shows what bloom looked like probably later in the same day after spraying Regalian oil. And you see the petals are shriveling up, they're turning brown. So that is a visible, clear effect of spraying Regalian oil during bloom, but it may not really have the effect of being toxic enough to actually kill the flowers so that they will not be able to be fertilized and develop into fruit. So that's all I have to share about what we did. I just want to acknowledge again that we received some funding for this trial from the USDA SARE program, and to reiterate that there is more information about what we did, about the pollen tube growth model, in the links below the video. Thank you.